On this page, we'll talk about surjective functions, which is also sometimes called onto functions. All right, so surjective and onto are basically the same thing. So what do we mean when we say that something is surjective? What do we mean when we say a function is surjective? Okay, so to be surjective, given any element in the codomain y, it is possible to find a pre-image x. So basically, everything in the codomain has a pre-image. That's what we mean by onto, or by surjective. Also, the negation of the definition is down here. This is helpful when you want to say, no, something is not onto. So how do you know that something is not onto? To show that something is not onto, all you have to do is find a y-coordinate that does not have a pre-image. So if you can find a y-coordinate that doesn't have a pre-image, then the function that you're working with is going to be called not onto or not surjective. Okay, so this is best explained if we do a problem. So let's take a look at a bubble situation. So consider these two situations over here with the two bubbles. So the first one, is that an onto function? Well, again, first of all, to be called an onto function, you must be a function in the first place. So how do I know if it's a function or not? I check the elements in the domain. Do they all have one single arrow going out of them? If you have 0 arrows or 2 or 3 or 4 more arrows, then it's bad. It has to be 1 arrow per element. So they all have 1 arrow per element, so that's great. Now I look over to the second side. Do all the numbers in the second bubble have an arrow pointing to them? In this case, unfortunately, the W does not have an arrow. So this is not an onto function. So this is not onto in this case. Now, if I look at the second situation, I look at the A, it has 1 arrow. I look at the B, it has 2 arrows. And I look at C, it doesn't have any arrows. So unfortunately, that problem is not a function. B does not have, well, C does not have any arrows and B has too many arrows. That's what I meant to say. So that means that the thing is not even a function. So does it make sense to talk about whether it's onto or not? No, it does not make sense to talk about whether it's onto. Because it's not even a function in the first place, we don't care if it's onto or not. By the way, I mean, in this case, the U, V, W, they all have an arrow to them. But unfortunately, that situation is not a function, so it doesn't make sense to talk about whether it's onto or not. Now, suppose I erase that last arrow and I make an arrow going from C to W like that. Then this becomes yes, it's a function, and now it's onto. A, B, C both, or all 3 of them have an arrow coming out of them, not too many, not too few. And U, V, W, all the elements in the codomain have an arrow pointing to them. So that means the function is now onto.